Hello everyone. For a given circuit, we have to find current in 2 ohm resistor by using KVL. So if we analyze any circuit, we have to follow two laws for finding a current. One is mesh analysis, other one is nodal analysis. For mesh analysis, we apply KVL, and for nodal analysis, we apply KCL. So if you for Kirchhoff's voltage law, first you have to follow some basic rule. We have to define current in a loop. This is first current loop. Current is I1, and this is second current loop, that is current is I2. So for applying a KVL, we have to follow some basic rule. First, we analyze current in each individual loop, that is I1 and I2. Then we define polarity in each circuit element. For resistor, this current I1 is flowing. For current I2 is flowing in resistance 1 ohm, and this current 2 ohm, we can assume both the direction, that is I1 is flowing is clockwise and I2 is flowing in second loop in clockwise. And if you see the resistor of 2 ohm, this is flowing from B to C for I1 and C to B for I2. So the net current will be I1 minus I2 or I2 minus I1. If you assume the net current is I1 minus I2, then the current direction will be B to C and the value will be I1 minus I2. That is very simple. If you have to see circuit element current direction, if you see the 1 ohm resistor, 1 ohm resistor having current direction for I1, and this is current direction another 1 ohm, that is I2. If you see the circuit element 2 ohm from B to C, this loop current I1 is B to C and this loop current I2 is from C to B. That means the net current is I1 minus I2 or I2 minus I1. If we fix the direction, that is B to C, then the current will be I1 minus I2. If we fix the current direction C to B, then current will be I2 minus I1. So we have options to decide a current direction if there is two different direction of current flowing in a circuit element. So you can see all the circuit elements are given for a current direction, and we assume all the current direction, then apply polarity. For this current direction I1, this is plus, this is minus. Current always flow from higher potential to lower potential. For this current, this is plus, this is minus, and for this current, this is plus, this is minus. And voltage polarities you always know, this is plus, this is minus, and this is plus, and this is minus. And if you see the path, this is A, B, C, D, E, F. So you can say there is two loops for current I1 and current I2, and for applying KVL we have to select a path. There are two independent variables, so we select two paths for calculating two independent value. Then we select one path A, B, C, F, A. Now apply KVL from A to B. There is fall in voltage. Current is I1 into 1. And from B to C, there is fall in voltage. Current is I1 minus I2 into 2. From C to A, there is a battery 2 volt, or you can say there is rise in voltage, that is plus 2 is equals to 0. So our current equation is minus I1 and minus 2I1 plus 2I2 plus 2 is equals to 0, or you can say 3I1 minus 2I2 is equals to 2. This is our first KVL equation. Now come to the second loop, loop B, D, E, C, B. Write KVL equation from B to D minus I2 into 1. Next D to E or D to C, you can say a battery that is given fall in voltage, that is minus 1. And now our next element is 2 ohm. C to B, there is rise in voltage, see the polarity, and their current is I1 minus I2 into 2, that is voltage is equals to 0. You can say I2 minus 1 plus 2I1 minus 2I2 is equals to 0, or you can say 2I1 minus 3I2 is equals to 1. This is our second KVL equation. So solve these two equations, you will get the answer. I1 is equals to 0.8 ampere and I2 is equals to 0.2 ampere. Now this is the basic concept of applying a KVL in a circuit. So current in 2 ohm resistor, that is I1 minus I2, that is 0.6 ampere. Thank you. Please like and subscribe my channel.